Hi, my name is Shubro Ghosh. This is pronounced as Shru and Bro with a BH sound, so it's like more like Vro. So it's like Shuvro. And this is like Ghosh but with a H sound, so it's Ghosh. So my name is Shubro Ghosh. Let me rewrite that. And this is the introductory video. So let me, start with introducing myself. So I've worked for many years in healthcare IT and clinical data systems. So let me write that down. Healthcare IT, and specifically in the clinical data systems of US Veterans Administration. And at the San Antonio University of Texas Health Science Center. This is San Antonio. And I've worked in the US for about 15 years. And I've come back to India and as an entrepreneur, and I've worked on health information exchange, electronic health records, and other clinical data systems, and also as a consultant on various projects. So as a entrepreneur as well as a consultant. So I've worked for 15 years in the US, and in India almost like another 10 years. So that's a sum total of 25 years. I've worked in this particular domain of expertise, and which includes EHR data, hospital data, research data, SQL databases, SAS. I've worked with transport systems like HL7 and FHIR, which is pronounced fire but written FHIR. I've worked with clinical codes, different kinds of clinical codes and data warehouses. But this particular series is essentially more about healthcare IT with respect to artificial intelligence. And more specifically, I want to see the data underneath it. And for that, this is a course in linear algebra, and it's one of the most important structures that need to be understood, mathematical abstraction structures that need to be understood before we can understand machine learning or artificial intelligence. So I want to teach linear algebra in this particular series, but not as some kind of a scary mathematics that um, inhibit understanding, but more visually, as a language that is behind many of the things that happen in healthcare IT, as well as machine learning um, and deep neural networks, that sort of things like vectors, matrices, spaces, and transformations. Because these are not just textbook ideas. They are how modern AI turns the world into numbers and helps us find patterns. So this series is for students, programmers, doctors, engineers, healthcare people, and anyone curious to learn about. So the audience is sort of wide, and we will, as I said, try to keep it visual, simple, and honest. And we will begin with one very small idea, which is the vector as a visual object that we understand as an arrow. We will understand matrix not just as a rectangular bunch of numbers, but as a transformation. And we will get into healthcare data as part of the application. So the idea with healthcare and AI right now is that we have a lot of bad data, and we understand that bad data plus powerful AI can actually be a disaster in some respect, because we know what hallucinations are and confabulations are. So this can lead to confident mistakes. Now, when a chatbot is confident and it hallucinates about something, or as Jeffrey Hinton likes to use the word, confabulates, it may or may not involve a person's health or whether he lives or dies. But when we are talking about this data belonging to healthcare, there is a problem, because that confident mistake can actually lead to worse outcomes for not just one patient or a particular prognosis of a disease or treatment for one patient, but for an entire hospital or chain of hospitals where, for example, this powerful AI is implemented without understanding the underlying structure of healthcare data. And to understand that underlying structure of healthcare data that is useful um, to understand the mathematics, and specifically linear algebra, because it is how that data, it may be in a SQL table, it may be in plain text, it ultimately, when we are talking about data being fed into the AI system, it has to be embedded, which is they're converted into numbers, and these numbers are either vectors or matrices. So it is very important to be able to understand the mathematics, which is linear algebra, and how it works. So this is the first introductory video. I want to sort of stop here, and from the next video in the playlist, I will start talking about the way I wish to present linear algebra to a beginner, to an audience which is wide and wants to understand the underlying structure of data as it is used for feeding it into an AI for a better healthcare outcome. The human proclivity is to think that we can simply abstract away layer on layer and expect software systems to work seamlessly without human intervention and understanding. But as far as the current state of the art for AI is concerned, it would be very risky for anyone in healthcare IT to not have a very good grasp over the subject of healthcare data and healthcare IT in general, and underlying mathematics of linear algebra, before they can gainfully employ layers of abstraction, AI abstraction, one on top of the other. So that is the aim and goal of this particular series.